Obesity isn't just about what we eat or how we live. Sometimes it's written in our genes. Monogenic obesity syndromes are rare but powerful. Single gene mutations can lead to severe early-onset obesity. These conditions come with unique physical and developmental features. From leptin signaling defects to syndromic monogenic obesities like Prader-Willi, Bardet-Biedl, and Alström syndromes, understanding these syndromes is important for tailored treatment. They help us unravel the complex puzzle of obesity itself. Welcome to our presentation on monogenic obesity. Today, we will explore the clinical aspects of monogenic and syndromic forms of obesity, focusing on genetic influences and their implications for treatment. Obesity affects over 1 billion people globally, with a rising prevalence. While most cases are polygenic, rare monogenic forms account for less than 5%, often presenting in early childhood with severe obesity and excessive eating, also known as hyperphagia. The pathophysiology of obesity involves complex gut-to-brain hunger signaling. Key hormones and receptors regulate appetite and energy expenditure, influencing the balance between feeling hungry and full. Leptin, a hormone secreted by fat cells, promotes satiety by activating pro-opiomelanocortin, or POMC neurons, to release alpha-melanocyte-stimulating hormone, or alpha-MSH, which binds to melanocortin-4 receptors, or MC4R, to reduce appetite and increase energy use. Leptin also inhibits neuropeptide Y, or NPY, and AGRP neurons, which are responsible for stimulating hunger. On the other hand, ghrelin, released from the stomach during fasting, activates NPY-AGRP neurons to promote appetite. Any dysregulation in any part of this circuitry, such as leptin, POMC, or MC4R mutations, can lead to persistent hunger and monogenic obesity. Monogenic obesity results from a single gene mutation, significantly impacting body weight regulation. It often leads to severe early-onset obesity and may be accompanied by neurodevelopmental or endocrine features. Monogenic obesity can be categorized into classical, syndromic, and hormone resistance types. Each category has distinct genetic causes and clinical features, such as early-onset obesity and hyperphagia. Now let us look at specific types. Prader-Willi syndrome is a rare genetic disorder caused by the loss of expression of paternal genes on chromosome 15, typically due to a deletion, uniparental disomy, or imprinting defect. It is usually sporadic, though it can be inherited through genomic imprinting mechanisms. A hallmark feature is early-onset obesity, driven by an insatiable appetite and decreased energy expenditure. Classic signs begin in infancy with hypotonia, poor feeding, and failure to thrive, later progressing to ravenous appetite, rapid weight gain, short stature, small hands and feet, and developmental delay. Additional features include mild to moderate intellectual disability, hypogonadism, and behavioral issues such as stubbornness, compulsivity, and temper tantrums. Diagnosis involves DNA methylation analysis and hormonal evaluations. Management of Prader-Willi syndrome includes growth hormone therapy, strict food supervision, and behavioral therapy. Albright hereditary osteodystrophy, also known as pseudohypoparathyroidism type 1A, is a genetic disorder caused by mutations in the gene S gene, which leads to resistance to parathyroid hormone. It follows an autosomal dominant inheritance pattern. It is characterized by a constellation of physical and hormonal features, including short stature, brachydactyly, especially of the fourth and fifth metacarpals, a round face, subcutaneous ossifications, and mild intellectual disability. Additional findings include developmental delay, ganglia calcifications, hypogonadism, pseudo-hypoparathyroidism, and dental abnormalities. A hallmark feature is obesity, which often begins in childhood and is typically centrally distributed. The diagnosis is supported by clinical features, biochemical evidence of hormone resistance such as elevated PTH with low calcium. Diagnosis is confirmed by genetic testing for GNAS mutations. Management involves calcium and vitamin D supplementation, hormone replacement therapy, e.g., thyroid, sex steroids, and nutritional support to address obesity. Bardet-Biedl syndrome involves multiple genes affecting primary cilia, leading to multisystem involvement. Key clinical features include early-onset obesity, retinal dystrophy, often presenting as night blindness and progressive vision loss, polydactyly, intellectual disability, and insulin resistance or diabetes mellitus. Critically, BBS is associated with renal anomalies and progressive renal dysfunction, which represents a major source of long-term morbidity and mortality in affected individuals. Diagnosis of Bardet-Biedl syndrome is based on clinical criteria and genetic testing. Management includes vision support, renal imaging and monitoring, nutritional interventions, with a focus on multidisciplinary care. Alström syndrome is a rare autosomal recessive disorder caused by mutations in the ALMS1 gene, leading to dysfunctional ciliary signaling and intracellular transport that affects multiple organ systems. It is characterized by childhood-onset obesity, sensorineural hearing loss, insulin resistance with acanthosis nigricans, type 2 diabetes, hypertriglyceridemia, hypogonadism, and progressive cone rod dystrophy, which often leads to early blindness. Cardiac involvement, particularly dilated cardiomyopathy, along with hepatic and renal disease, contributes to significant morbidity. Diagnosis is confirmed by genetic testing for ALMS1, with supporting evaluations from audiology, ophthalmology, endocrinology, and cardiac imaging. Management is multidisciplinary, focusing on regular monitoring of visual, hearing, cardiac, and metabolic health, endocrine management of diabetes and lipids, use of hearing and visual aids, and nutritional and behavioral strategies for obesity. Cohen syndrome is a rare autosomal recessive disorder caused by mutations in the VPS13B gene, characterized by a constellation of developmental and physical abnormalities. The hallmark features include truncal obesity, hypotonia, intellectual disability, microcephaly, and retinal dystrophy, which can lead to progressive vision loss over time. A distinguishing clinical aspect is neutropenia, predisposing patients to recurrent infections. Additionally, patients often have distinctive facial features such as thick hair, prominent upper central incisors, and a generally characteristic facial appearance. Diagnosis is confirmed by genetic testing and CBC for neutropenia. Multidisciplinary care is essential for management. Carpenter syndrome is caused by RAB23 mutations, disrupting embryonic development. Features include craniosynostosis, which is premature fusion of skull bones, polydactyly, developmental delays, congenital heart defects, and childhood obesity. Diagnosis of Carpenter syndrome includes genetic testing and imaging for craniosynostosis. Management focuses on surgical intervention, nutritional support, and early developmental therapies. Leptin deficiency is a rare autosomal recessive genetic disorder caused by mutations in the LEP gene on chromosome 7, leading to an absence of leptin, a hormone that signals satiety to the brain. Without leptin, individuals experience uncontrolled hunger and early-onset severe obesity, often within the first few years of life. Affected patients may also exhibit hypogonadotropic hypogonadism, resulting in delayed puberty. The hallmark of this condition is dramatic weight gain that is unresponsive to conventional dietary interventions. Management includes recombinant leptin therapy, metroleptin, which restores satiety signaling, significantly reduces appetite and body weight, and improves metabolic and hormonal parameters. The striking response to leptin therapy, as seen in the before and after images of affected children, underscores the importance of genetic diagnosis and targeted treatment. Melanocortin-4 receptor deficiency is the most common monogenic cause of obesity, resulting from mutations in the MC4R gene on chromosome 18 and follows an autosomal dominant inheritance pattern. It leads to impaired melanocortin signaling, causing loss of appetite regulation, early-onset severe obesity, excessive hunger, and often increased linear growth and lean body mass in children. Diagnosis is made through genetic testing and clinical suspicion based on family history of autosomal dominant obesity. Management includes setmelanotide, a targeted MC4R pathway agonist approved for treating obesity due to MC4R pathway defects, along with behavioral and dietary interventions. Pro-opiomelanocortin deficiency is a rare autosomal recessive genetic disorder caused by mutations in the POMC gene on chromosome 2, resulting in a deficiency of key peptides such as ACTH and MSH. This leads to impaired adrenal function and disrupted appetite regulation. Affected individuals typically present in infancy with severe early-onset obesity, hyperphagia, and adrenal insufficiency characterized by low cortisol levels, hypoglycemia, and hypotension. They often exhibit pale skin and red hair due to reduced melanocyte stimulation. Diagnosis involves genetic testing and hormonal assays revealing low ACTH and cortisol levels. Management includes setmelanotide, an MC4R agonist that targets appetite regulation, and hormone replacement therapy, e.g., hydrocortisone, to address adrenal insufficiency. Early recognition and treatment are crucial to prevent life-threatening adrenal crises and manage obesity. This summary table outlines various monogenic obesity syndromes, highlighting key features, inheritance patterns, and treatment options. Understanding these syndromes aids in targeted management and care. Thanks for watching. Please like, share, and subscribe.